everyone. My name is Varun, and in this presentation, I'll be talking about my project, which is on language identification using deep learning with RNN approach. Now, let's talk about the problem statement. The main problem statement of my project is to identify an audio language from a particular audio clip. Whenever I input an audio clip, which is of a certain language, especially in this case, I have used three languages, that is English, German, or French. So if I input any one of these three languages, our model has to predict which language it is. Now, this is a very useful thing because it can be used by various voice assistants. As we know that voice assistants do have a feature where they can identify languages, and there is also a translation happening which requires identification of the correct language. It can be used in transcription services and translation tools. Now, it matters. This project matters because it can be used for multilingual voice assistants, customer support systems, and audio content classification. So the overall objective of this project is to classify audio clips into three languages, that is English, French, and German, using an RNN model. Now let's talk about the dataset used for this project. Now I have used the dataset from Mozilla Common Voice, which is an open source project which collects various audio clips from the users. It allows users to record and share their voice. It has various languages. I have particularly picked three languages, that is English, German, and French. The audio clips are in MP3 format. For this particular project, I have resampled them to 16 kilohertz. In my project, I have used MFCCs to capture features from this audio clips, which I have downloaded from Mozilla Common Voice. I'll talk about that later. And also for this project, I have split the data, that is the features which were extracted from the audio clips were split into 80 and 20 for training into the model. Now, every zip file which I have downloaded for a particular language included two TSV files. One TSV file listed various metadata like the client ID of the particular audio file, which is the unique ID of that audio file, and the path of it, and the sentence which was used in the audio file, and various other things like age and gender. And there was another file which showed the duration of each clip. Now, to clean this data, the main thing which I was planning was to merge various TSV files of three different languages into one big file. Yeah, now coming to the cleaning, the main thing here is I plan to combine. I had four different TSV files, two of English, one of German, and one of French. So I have combined everything into one big file, one big TSV file, including their duration for each clip. Now, initially, I have checked the number of hours present for each language. I have observed that it was not balanced. German had the most number of hours, around 19 hours of audio recording. So what I've done is, since the least one, which was French, was around 9 hours, I have made every language converted every language just for 9 hours of audio recording. So this ensures that I have balanced the training hours for each language when I move into model training. We can see from the picture here that this is the original unclean data, which was a TSV file of metadata of the audio clips. I have converted into this clean data where I have removed various unnecessary columns like age, gender, and accent. It just includes the path, the sentence used, the language, and the clip name, and the duration in seconds and hours, duration in milliseconds and seconds. Now, after completing the cleaning of for the TSV files, now we move on to feature extraction, where we can use the TSV files to locate the clip and extract features from it. Now, I used MFCCs here, which is mel frequency septal coefficients, for extracting features. I have used this because it is widely used for audio analysis as they capture human voice characteristics. The main step here is I first load the data, then it is resampled to 16 kilohertz, then MFCCs are extracted for that in coefficients, and then I have padded the sequences to maintain uniform length across all of them. Now we can see a heat map over here. It's a sample heat map for one sample. for the MFCC features which are extracted. Here we can also see the average MFCC features per language, which is consistent across 3 languages. Now, after extracting features, we have 3 labels here, which is English, German, and French. Since RNN doesn't take in string features, what I've done is I've encoded them into numerical, which is 0 for English, 1 for French, and 2 for German. After that, I have for better processing in neural networks, I have encoded them into one hot encoding. So we can see a sample label here, which is in matrix form. Moving on to the architecture of my neural network, as I've told before, I have used a recurrent neural network, which is RNN in this case. Now, why I have used RNN? Because it captures sequential data, in this case, which is audio, better than traditional models. Now, in RNN, I have used LSTMs, which helps address the vanishing gradient problem, enabling the model to retain information over longer time steps. The main architecture here is I have used 2 LSTM layers. The first layer has 128 into 94 into 128 units. Then it is passed on to the second LSTM layer. Then after that, a dense layer was used with which has 128 units. Then a dropout layer was used to reduce overfitting. Then finally, I have used softmax to classify the 3 classes into English, French, or German. The input shape here is time steps and MFCC coefficients, which is 94 and 13. Now coming to the training and validation of my model. For the training setup, I have used 50 epochs. I have previously told my dataset was split into 80 and 20, 80 for training and 20% for testing. And the batch size which I have used was 32, and I have used the sparse categorical cross entropy for loss function and Adam as optimizer. Now, overall, my model has come out to get an accuracy or validation accuracy value of around 81.7%, which is approximately 82%. We can see the training and validation accuracy for RNN here and training and validation loss for RNN in this graph. We can see that as we move through the epochs of 50 epochs, the training and validation accuracy has been consistent. Now, moving on to the evaluation of the model. As previously discussed, the validation accuracy of model has come out to around 82%, and the validation loss was around 0.87. Now, as we can see from the confusion matrix here and the classification report, the model yielded a very good result of around 82% for accuracy. And even when it comes to precision recall and F1 score for 3 different classes, the results were pretty consistent, and it was around similar values for various metrics. One thing we can say that is that the model has the best results when it comes to predicting French class, and it can perform better when it comes to German because when it comes to the precision of German, it is just 73% because it was struggling to classify German, distinguish between German and English. It can be due to the same pronunciation of different letters. That could be one thing which was getting German to less precision. This could be improved if I have done it over a more number of epochs, or I have included a larger number of training hours for all these 3 instead of just 9 hours. So after I was done with getting the results for validation accuracy, what I've done was I have taken an unseen French audio clip and I tested it. So the testing process is in this way. So initially the audio clip was pre-processed. Then using MFCCs, I have extracted the features and passed it to RNN to get the predicted language. From the new audio clip, what I have tested, I have found out that it did predict the correct language as French. So when it comes to testing for unseen audio, it was doing pretty well. So overall, when it comes to overall concluding, I can say that this project aimed to build a system where it was possible to upload an audio clip to classify it into 3 different languages, that is, whether it is English, French, or German. Overall, an RNN model which was used here had resulted an 82% of validation accuracy, which shows that the model was performing really well. And some challenges which I faced while doing this project was to balance the dataset to avoid bias. Since I've told that initially the training hours, number of hours which were present were not equal for all the languages, so I had to balance it around. So I have to figure out a way to get the durations in and get everything into 9 hours. And also, the initial data set was so huge because I was having around 21 hours for German, around 15 hours for English, and around, I guess, 9 hours for French. So uh, combining three, it was a pretty large data set, so I had to handle that as well. So in future, what I can say that is to improve this model, I can use various other neural network models like CRNN or some pre-trained models like Wave 2 Vector 2. And I can use even more training hours. There is actually the Mozilla Commons audio source which I used for getting the dataset. Indeed has a very large number of training hours. I can download and use that. It has around 100 hours for each language. I can use that to improve the generalization for model to get the better accuracy results. So overall, yeah, this concludes my presentation of my project. Thank you.